Hello, today we're here to present our Kaggle project. It's a movie recommendation system. We have 4 group members. They are Yusuf Benjilu, Wang Zeyao, Wang Chengzhi, and Zhongmi. This is content of our first presentation. First, we'll have a brief introduction of our data, and then we'll go deeper. We have a full analysis of our data, and then we'll present the business and the technical in this project, in this recommendation system. And the last part, we'll introduce our future analysis, which means we'll introduce the method and algorithm we'll use in the future project. The first part is the data introduction. This data was generated from the movie database API. The movie database is a community-built movie and TV database. We can see from the chart that it has like about 5,000 movies, which from 1960 and 2070. And for each movie, it has 20 variables to describe it. Apart from the numbers, including budgets, revenues, runtime, average score, and the total vote, and vote average, it is the variables, continuous variables. It also has some variables like that use words and sentence to describe the movie, like words, tagline, overview, and etc. So in our recommendation system, we can make a recommendation in 2 dimensions, both continuous variables and discrete variables.
My name is Yusuf Benjelloun, and I'm going to present our statistical analysis. So we've made a summary of the numeric variables to begin with, so we can have an overall look of our dataset. Our first variable is the movie budget. We observe that its minimum value is 0, which means that in our movie dataset we have movies with no budget, so we assume that. Popularity is another variable that is interesting to observe. Its minimum value is almost 0 and its maximum value is around 875. When the mean is equal to 35.7, the maximum value is very distant from the other observations. We can guess that it's an outlier and we can choose to keep it or remove it as the other outliers to get better graphic results. As for popularity, we have outliers. For the release date, we have a 1937 movie. We also have movies with no revenue, so we assume that it exists. We have movies with no runtime, which is probably an error because this doesn't exist. So we will correct it before we go further in the future. With all these variables, we can do many things, and so at first we chose to observe movies with no budget, especially the most popular ones and the resulted revenue. For our second most popular no-budget movie, we can see that it produced a large revenue, while the third most popular no-budget movie made no revenue. On the histogram on our left, we see that we have a bit more than 1,000 movies with no budget. We decided to check if there is a correlation between variables. As we would predict on our right, we see that we have a strong correlation between the movie budget and the revenue. More the producers invest on the movie, better the revenue is. By intuition, we would think that a movie with a better vote would be more popular than the rest of the movies. Now let's see how true this is. On our left, we see that we have a weak correlation between the vote average and the popularity of a movie. The first observation is that the majority of the vote average values are between 4 and 8, which is not that bad. The other good information for the producers is that the popularity of the movies is almost the same for the movies with a vote average between 6 and 8. We can also observe on this graph the 6 outliers with a high popularity. On our right, we observe that the further we go in time, people are more likely to vote movies, but also a lot of movies are left without votes.
And then let me have an introduction about the business goal and the technical goal. It has 2 functions. The first one is create a simple recommendation function that suggests 5 movies based on a selected genre and a selected language. And the second one is suggest 5 movies based on similarity of the top 3 actors and top 3 genre and the director. In order to achieving the business goal, first of all, I calculated a weighted rating for all movies. I used the formula that IMDb also uses for its ratings. This formula takes both the vote average and the number of votes into account. And the first one is the simple recommenders, and it offers generalized recommendations to every user based on movie popularity and genre. The basic idea behind this system is that the movies that are more popular and critically acclaimed will have a higher probability of being liked by the average audience. In this system, we would like to use weighted rating to get the top 5 movies based on selected genre and language. By example, here we use English. We want to choose English drama top 5 movies. And finally, we expect to get a recommendation table like that. And the second one is content-based recommendations. In these recommendations, I composed a function that recommends 5 similar movies for a movie. All these movies based on the number of similarities. And the second one is when the number of similarities is the same for a number of movies, I'm sorting them on a descending weighted rate. And finally, we would like to get a table like that. And in order to improve these recommendations, I could add more content to match, such as top 3 keywords. Another thing that I could do is to change the weights. For instance, if I double the weight of the director, this changes the last recommendation for the Titanic. The 5th recommendation is now a movie also directed by James Cameron.
And then I will talk about our future analysis. What we want to do is recommend some similar movies based on the movies the user has researched for. So we want to make a function that the input is a movie and the output is the movies similar to it. How to do that? We will use something that we will learn in the lecture 10. For example, we will use content-based recommendation. It is based on the information of the movies. For example, genre, language, or actors to make recommendations. Perhaps we will use a method that we had learned in the last semester, K-nearest neighborhood. Further, we will study the item-based filtering, and then we want to study whether the IMDb scores of similar movies are close. According to the lecture 7, we will make a hypothesis like that. We let the scores for some similar movies be the X, and we make 2 hypotheses, and then we try to use maximum likelihood ratio test for comparing them. Finally, we will visualize the result.